Hello everyone. In the previous class, I was discussing about the solubility of gas in liquids as well as the effect of temperature and pressure on the solubility of gas in liquids. And we have also studied about the Henry's law. So the statement for the Henry's law will be the partial pressure of a gas in a vapor phase is directly proportional to the mole fraction of a gas in a liquid or in a solution. That is, P is directly proportional to X, where P is the partial pressure of a gas, X is the mole fraction. Therefore, P is equal to Kh into X, whereas Kh is the Henry's law constant. So, today we are going to solve some numerical problems related to the Henry's law. Okay. Now, let me read the question first. If nitrogen gas is bubbled to water at 293 Kelvin temperature, how many millimoles of nitrogen would dissolve in 1 liter of water? So the question is, how many millimoles of nitrogen gas would dissolve in 1 liter of water? Assume nitrogen exerts a partial pressure of 0.987 bar. What they have given? The partial vapor pressure of nitrogen gas. How much? 0.987 bar. Next, given that Henry's law constant for nitrogen at 293 Kelvin is 76.48 kilobar. Okay, they have given the Henry's law constant, that is Kh value. How much? 76.48 kilobar. Okay. So what is Henry's law? The statement for the Henry's law is the partial pressure of a gas in a vapor phase is directly proportional to the mole fraction of a gas in a solution. That is, P is directly proportional to X. That is, P is equal to Kh into X. Whereas P is the partial pressure. P is the partial pressure of gas. Kh is the Henry's law constant. X is the mole fraction. Here, the solute is nitrogen gas. It is dissolved in 1 liter of water, means water will be the solvent. Solute is the nitrogen gas, solvent is the water. Okay, what they have given us? They have given us to calculate the millimoles of nitrogen gas dissolved in 1 liter of water. So, in order to calculate the millimoles of nitrogen gas dissolved in 1 liter of water, you should know how to calculate the moles of nitrogen gas. So, from where you have to calculate the moles of nitrogen gas? By using the mole fraction. So, you know that mole fraction is the number of moles of solute divided by number of moles of solute plus number of moles of solvent. That is, X is equal to N solute divided by, that is number of moles of solute divided by number of moles of solute plus number of moles of solvent. So, this is the formula of your mole fraction. Okay. So, in order to calculate the millimoles of nitrogen gas dissolved in 1 liter of water, you have to use the mole fraction formula. Okay. Now, let me write the given data first. What we have given? Assume nitrogen gas exerts a partial pressure they have given. Okay. How much? Partial pressure, that is P. P is how much? P is equal to 0.987 bar. 0.987 bar. Again, what they have given? Henry's law constant, that is Kh. Kh is equal to how much? 76.48. 76.48 kilobar. See? Listen here. Here the Kh value is in kilobar and pressure is given in the bar. So now I would like to convert this kilobar into bar. That is 76.48 or 76,480 bar. 76,480 bar. I have converted this kilobar into bar. That is 76,480 bars. Now, in order to calculate the millimoles of nitrogen gas, first we have to calculate the moles of nitrogen gas, then we have to convert it into millimoles. Okay. Now we know the value of P and Kh, and now we would like to calculate the mole fraction. Now put the values of partial pressure and the Henry's law constant. See, therefore mole fraction of nitrogen gas X into is equal to P divided by kH. P divided by kH. See, the partial vapor pressure is how much? 0.987 bar. 0.987 bar divided by kH is how much? 76,480 bar. So bar and bar get cancelled. This ratio will be the how much? 1.29 into 10 to the power minus 5. So this is the mole fraction of nitrogen gas. So this is the value of mole fraction of nitrogen gas. By using this value, you can calculate the number of moles of nitrogen gas dissolved in 1 liter of water. So we know the formula of mole fraction, that is xN2 mole fraction. xN2 is equal to nN2 divided by nN2, that is number of moles of solute divided by number of moles of solute plus number of moles of solvent. Here the solvent is water, that is NH2O. NH2. See, what we know the value of xN2, and we have to calculate the number of moles of nitrogen gas. See, this is what we have to calculate, and now we need to calculate the number of moles of water. So how we will calculate the number of moles of any solute or solvent? There is one formula, n is equal to mass divided by molar mass. Mass divided by molar mass. Now I am calculating the number of moles of water. Okay, number of moles of water. How much they have given? 1 liter of water. So 1 liter of water means how much? 1000 ml. Okay, if you consider the mass, then for 1 ml it will be the 1 gram. For 1000 ml it will be the 1000 gram. So therefore, mass of 1 liter of water will be, that is 1000 gram. 1000 gram divided by molar mass of water. If you calculate the molar mass of water, then it will be the 18 gram per mole. 18 gram per mole. If you calculate it, you will get the 55.56 moles. Gram get cancelled, and we will get the number of moles of water. How much? 55.56 moles. Okay. Now we have calculated the number of moles of water. Now we need to calculate the number of moles of nitrogen gas dissolved in the 1 liter of water. Okay. In the beginning of the class, in the beginning of this session, I have told that the dissolution of gas in the liquid is very low. Therefore, the number of moles of nitrogen gas is very less as compared with the number of moles of water, that is 55.56 moles. Therefore, the number of moles of nitrogen gas in the denominator it could be neglected. Therefore, our formula will be xN2 is equal to nN2 divided by NH2O. So we know the value of xN2, we know the value of NH2O, and now we have to calculate the number of moles of nitrogen gas. So now put the value. Okay, modify this formula equation. nN2 is equal to xN2 into NH2O. xN2 is how much? 1.29 into 10 to the power minus 5 into NH2 is how much? 55.56 moles. Okay, we will get the value how much? 7.16 into 10 to the power minus 4 moles. So this is the number of moles of nitrogen gas dissolved in 1 liter of water. But in the question what they have given? They have given us to calculate the number of millimoles of nitrogen gas. Okay. Now I would like to convert this moles into millimoles. I will multiply it by 10 to the power 3, 7.16 into 10 to the power minus 4 into So you will get the how much? 0.716 millimoles. 0.716 millimoles. So it means what? 0.716 millimoles of nitrogen gas is dissolved in the 1 liter of water. Okay. See, we know the Henry's law constant equation, that is P is equal to kH into x. What they have given? They have given the partial pressure and kH value they have given, and from using these two values, I have calculated the mole fraction of nitrogen gas, that is Xn2. Xn2 will be 1.29 into 10 to the minus 5, and we know that mole fraction formula Xn2 is equal to N(N2) divided by N(N2) plus NH2O, that is number of moles of solute divided by number of moles of solute plus number of moles of solvent. And before that, we have to calculate the number of moles of water. So therefore, how we calculate the number of moles of water? That is mass divided, N is equal to mass divided by molar mass. Mass, how much they have given? 1 liter. Volume they have given 1 liter of water. So 1 liter is equal to how much? 1000 ml. And in mass, the 1 ml will be the 1 gram and 1000 ml will be the 1000 gram. So therefore, the mass of the water is how much? 1000 gram divided by molar mass of the water is how much? 18 gram per mole. If you calculate this, you will get the 55.56 moles. That is, number of moles of water is how much? 55.56 moles. And I have neglected this number of moles of nitrogen in the denominator because the solubility of gas, nitrogen gas in the liquid is very less as compared with the number of moles that are dissolved. Number of moles of water, how much? 55.56 moles of water is that means this nitrogen gas dissolved in the water is significantly less as compared with the 55.5 moles of water. Therefore, I have neglected this number of moles of nitrogen gas from the denominator. So therefore, our equation will be Xn2 is equal to N(N2) divided by NH2O. And we have calculated the Xn2, and now again we have calculated the NH2O, that is 55.56 moles. Therefore, N(N2) is equal to Xn2 into NH2O. By putting all these values, we got the value, that is 0.716 millimoles of nitrogen gas dissolved in the 1 liter of water. Okay. So we have done with the first problem. Let us come to the second problem. This problem is from your textbook, from your NCERT textbook, in-text question, and the question number will be the 2.6. Okay. Let me read the question first. The H2S, a toxic gas with rotten egg-like smell, is used for the qualitative analysis. See, hydrogen sulfide is a toxic gas with a rotten egg smell, which is used for the qualitative analysis. If the solubility of H2S in H2O, solubility of hydrogen sulfide gas in water at STP standard temperature and pressure is how much? 0.195 moles. That is, this is the small m. So this small m is what? Molarity, not polarity. Capital M will be the molarity. If they given in the small m, then it will be the molarity. So what is molarity? Molarity is the number of moles of the solute dissolved in the 1 kg of water or 1000 grams of water. So what they have given, the solubility of H2S in water at STP, okay, is how much? 0.195 moles. Means what they have given, number of moles of H2S gas dissolved in the water. Okay, next calculate the Henry's law constant. Calculate the Henry's law constant. What you have to find out? You have to find out the kH value. See, let me write the equation first. P is equal to kH into x. X is the mole fraction, you know this. Okay. So standard temperature and pressure at STP, the pressure will be the how much? 0.987 bar. Okay, in bar. STP at STP condition. Okay, at standard conditions of temperature, standard conditions of pressure will be how much? 0.987 bar. Okay. See what they have given. P is how much? 0.987 bar. P is how much? 0.987 bar. And what they have given? They have given us to calculate the Henry's law constant, that is KH, we have to find out. And again what they have given, number of moles, mole fraction, number of moles of H2S gas they have given, means N H2S, number of moles of hydrogen gas, hydrogen sulfide gas dissolved in water. How much? 0. Concentration they have given 195 m. Okay. Now, in order to calculate the KH, that is Henry's law, we have to find out the mole fraction first. So mole fraction will be XH2S is equal to NH2S divided by NH2S plus NH2O. Hydrogen sulfide is the solute and the water will be the solvent. Okay. Now NH2S is how much? 0.195 divided by 0.195 plus number of moles of water. Already I have calculated number of moles of water is how much? 55.56 moles. 55.56 moles. If you calculate this, you will get the value 0.0035. 0.0035. Okay? Moles. Mole. Okay? Now, by using this value, you can calculate the KH. So, therefore, KH is equal to P divided by X. Partial pressure is how much? 0.987 bar divided by mole fraction of H2S gas is how much? 0.0035 is equal to, if you calculate this, you will get the 282 bar. 282 bar. 282 bar. Okay, how much? 282 bar of pressure. It is dissolved in the water. That is hydrogen sulfide gas. It is dissolved in the water. Okay, this is all about the numerical problems related to the Henry's law. Okay, I hope all of you understood these two problems. And now in the next session we will continue with the liquid solutions. Okay, in the first we have in the solubility we have first discussed the solubility of solids in liquids, and again we have discussed the solubility of gas in liquids, and now in the next session we are going to study about the solubility of liquids in liquid solution. Okay,